guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. This is as good a place as ever to bring in. It's a very unique competition 6-pill. There's some things in here I think are really cool, like the heavy duty surface mount capacitors. I don't dig the dual tuning. I don't like this or this. Not a fan of it. But we're just going to test drive it. Now, this has really got me concerned. It's aluminum dust, and it's literally on everything in here. So I don't know if they did that to try and sabotage my friend that sent this here for me to work on or what, but what we got here is a straight 6 with some very interesting tuning in it. Yeah. So I got the 2-pill, the 2950 5-watt slug, 1000-watt slug in 2X, 1000-watt slug in average, 5-watt slug in reverse. Here's our principle that we're putting into it. Okay. We're just going to tickle this thing and see. Yeah, power switch needs to be replaced too. See those side harmonics? Now we're making tremendous peak power. Look at this. About 17 and some change. That's 600 bird. If we shut off the 2-pill, input tune's not too bad. Here's our principle again. Okay. Amp off, driver on again. So that's just the 2-pill by itself. These little side harmonic hiccups that you see here, we've got to get rid of those. Now this is going for my friend Mr. R. And I think he's going to try and shoot out with this little 6-pill. And then I got another one over there. It's a straight 8 that I got to do also in this same video segment. There's things in here I like, and then there's things in here I don't like. I appreciate the combiner circuit. This I don't care for, so we're going to change that. And this I definitely don't care for, so we're going to change that and change this, change some other stuff in here. So let's look at our watt meter one more time. 1600 watts. And about 550 bird with this setup. So anything we do to improve it from here is a plus. Okay, we got our befores and we got our before. Let's go work on it and let's see what we get out of it for an after. Yes, sir. Well, we changed some stuff. Mr. R, first thing we did is we got rid of the long inductor capacitor or long inductor resistor deal here. This gone. Placed with 5 watts. We got rid of all the little antennas that are on the resistors. Those are inductors, by the way. I am kind of concerned about your capacitor. I haven't had a chance to check that yet. But we've got 5 waters here, 5 waters here, and then we removed this 470K surface mount capacitor here, which actually cleaned up your input tune quite a bit. The main thing though that we did is we went through and replaced these little guys, which I've had problems with them failing in key downs before. These things are great for the everyday talking box. They're not the best for when you go and put the box on 22 volts or 21 volts and key it at ass tonnion of watts. Those things have a tendency to heat up real fast and they break down. So what we did is we replaced them with metal clads. And we gave you the power wire upgrade. We washed the box. I do believe I had to change 2 of the input capacitors because they were in the wrong capacitance level. Now I did get rid of these 2 electrolytics. Made them one away because I needed to actually have capacitance coupled to ground on the positive lead to help throw the positive lead out of resonance. Then we added capacitance to the backside of each one of the output transformers to help null out some signals that we were having. Remember those 2 little signal points that we had in there that were off frequency? Gone. I tune better. Amp off. That's just the radio going directly into the amp. 2 pill on, 6 pill off. So now we have a much cleaner signal coming out of the box. More RF on frequency means more ability to whoop ass. It's real simple. Okay, so if I remember correctly, we were just barely touching the 80. It's 1000 watt slug and 2X, by the way. Now we're climbing past it. It wants more. And I think we were seeing about 500 bird, give or take, right? We're well over that now. Same exact setup. Just went in and refined the turd. Polished it up, made it shine a little bit. So now that we got all that out of the way, let's drop the 2950 out of play. And we're going to go to the D-Rail radio. Since this is what most of the guys are running in the shootouts these days, we're going to see what this thing does. As far as bird watts go, would not surprise me if we end up pegging this sucker in a corner. Oh, wrong microphone in the hand of the tester. Let's go up here and grab the microphone for the D-Rail radio. Hello. 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 Just about pinning a 1000 watt slug in a corner. Let's go over here and pull this 5000 watt slug out. I actually had a guy say to me in Pal Talk the other day that I don't ever use any of my slugs on my workbench. They're too clean, they're not scratched up, they're not dented, they're not dinged, so therefore they're not valid. And some of the stuff these guys say to each other is unbelievable. Okay, 5000 watt slug. Yeah, I put my shit in holders and I keep my stuff clean. Okay, 5000 watt slug in a hole. About 1200 bird. And that's on 14.5 volts. And that's with a substantial carrier too. 800 watt dead key. So it's not all swing. So don't be afraid to maul it up there a little bit, as they say. Now, we just pushed this box real hard. Let me hook up the tin to it. We're going to get some air moving on this. We're going to let it cool down. And when we come back, we're going to try it on 17 volts and see what we get out of it for max numbers. 17.1 volts. Still quite a few volts less than what you guys are going to run it at. I know that this thing's going to get hit with 21, 22 volts probably or more. So you're going to have to see what you get out of it. Remember, key it, let it cool down. Key it, let it cool down. Okay? Don't just key it and then key it and then key it and key it. You got to high the voltage. Remember, the heat's what kills the transistors. Same drive, same everything. 17 volts. So our peak slug in the corner. And our average slug, 5,000 watt slug, 14 and a half, 1,500 bird. I'll live comfortably with that. 2,000-ish watts peak, and 1,500 bird on the D-Row radio. You'll see more, much more. Anywho, okay, amp number 1 done. It's now like 3:30 in the morning. I'm gonna go get something to eat for breakfast, and I'm gonna come back and I'm gonna start in on amp number 2. So all this mess will be cleaned up, and there'll be another whole bag of love sitting here on a bench for me to work on. I shall return. Okay, part 2 here. This one's an X-Force. It's a straight 8. And as we can clearly see, it's been burned up a couple times. There's all burn mark all through here. There's burn mark all through here. Burn mark all through here. That transistor's obviously been replaced. And the other one that's been obviously replaced is here. Okay. So there's a lot of little things that I want to change, like this ground tab back here is broke off, no big deal. But this has got me kind of worried. So we're gonna fix that. We're gonna do the power wire upgrades on this thing, and I can't wait to see what the tune is like on this thing. So let's see what I'm hooked up to. The bench supply. All right, let's turn this on, put that at 1x, 5K slug out from the previous video, put in the 1,000 watt slug. Let's reach down here. Turn on the power supplies. And okay, so we're just going to tickle this and see what it does. We're on 14 volts. 21 watts of drive, right? Needs a new power switch, by the way, too. 480 watts. Alright, our input tune is not good. Okay, well, that gives us a baseline. Let's rip it all apart. And what I mean by that is we're going to go out and take these little amp restrictions out. We're going to replace resistors. We're going to clean up burn marks. We're going to replace the flybacks. You see, the flybacks in a competition box are really important. Any amount of drive that you put into this amp that isn't consumed by the transistors, it's only got one pathway to escape the box. It's through these resistors to be coupled, per se, back to the output transformer. Okay? These get hot, especially when you're driving them really hard, especially when you're driving at like 21, 22 volts, where these guys like to run. Hence the reason bigger parts. So, there's like spaghetti work in here. Let me do my thing. We're gonna change out some small parts. I do like the fact that it's got metal clads on the outputs. That's good. That's a good thing. So, okay, away we go. I'm out here kicking it with my black lab. Isn't that right, Mr. Tesla? I got the shop door hanging open about that far. So he's laying down on the ground and he's got his head stuck out underneath the door and he's watching the world go by and his head's doing this. His tail's back behind him going 100 miles an hour. Okay, so moving right along here. Never understood why guys do this. It's just stupid. Cut the jacket off the outside. Like we don't have $2 machines from China that can figure this out for us. So this is a bing bing 460 or 4,661 UF cap. Probably in the range of 25 to 30 volts. Is that cap test good? So what did I say that was? 4,661, right? This whole cap thing is kind of, it's still fun to do. It's good eye candy. And for guys that don't have super capacitors, this helps a little bit. Most of my guys now, they're all running super caps on everything. So this little bit of help electrically does very little, but it's better than nothing. And the whole idea behind this is to help keep the voltage ripple of the surge of on the key, off the key, on the key, off the key. Talked about it many videos. Very many videos. You guys should be experts like me now, yeah. Which I'm not an expert, I'm just a tinkerer. Okay. We're measuring. It's some good. It's good, yeah. $4,788. That's the best cap of them all. Here, we'll test it actually lead to lead. Needless to say, these caps aren't broken down, so I don't need to do anything with them at all. Solder this back down. As you can see, I've already got all the 5-watt resistors on this section done. The output section's done. We washed it real quick, got rid of almost the burn scorch mark. I'll put these caps back down. I'm going to finish doing all the resistors over here, which should take no time. We'll go ahead and do the power wire upgrade, but before I do any of that, I want to go through and make sure all the screws are tight on the transistors. Then we'll go through and we'll do a little bit of the fixing of this and put a lock nut on this, and then I want to look and see what's underneath the electrical tape and see if this even is soldered or not. And I'll probably pop these out of the Anderson clip and make sure they're soldered. Yeah, moving on. Well, we're at the tail end of this little deal. We've got, let me pan out here for a minute. These guys, I swear to God, I love them both. Good cats, both of them. Mr. B and Mr. R, they're running me in circles because they're getting really nervous. They're running out of time. They got to have these boxes here pretty quick. So what I did is I went through and I did all the power wire upgrades and did the resistor upgrades and checked all the input and output caps and checked each one of the section caps and just checked everything. Cleaned it all up, checked everything. And went through and, like this guy here, the Anderson clip on this thing, they were soldered, but, well, the positive wire was soldered and the Anderson clip was soldered, but the eyelet was very poorly soldered up here at the top. And so I went ahead and redid that, pulled all the electrical tape off, put heat shrink on everything for them, and then cleaned up the ground wire. Just that little small details. Cleaned it up so it didn't look like it had spooge all over it. It was all covered with flux or whatever, because I can tell they used like plumber's solder when they did this back here, this eyelet here, and it just dribbled all down the wire and it was gross. So now that we got it up and running, I mean, it was a running amp. But one of the things that I always like to go back and check, like usually when the transistors get put in, like when Carl and them guys, his group of guys are building these things, we know the transistors got screwed down tight from there. But like this one that got replaced, and I believe this one that got replaced, they were not tight. I was able to get literally, like on this one, a turn and a half on one and a good half turn on the other. They have to be tight, otherwise the transistor can't transfer the heat and it'll just burn up again. So we checked that. I added shorting bars, one here and one at the back. We've covered why we do that in multiple other videos. Let me just give you a quick rundown. If anything was to happen where half the power wires come disconnected, we don't want to have half the box drop out, cause an imbalance, and cause a box to burn up. So internally, we short these two distribution bars together. That way we don't have to worry about what's happening externally. It's an internal safety thing. The power will drop off, yes, but it'll still stay running. The other thing, I replaced this strap. I used this for a lot of years, and there's really nothing wrong with it. But I found with competition boxes, it's better if you have a solid connection. Because if you sit there, especially in a high flow amp box, something that's pulling like 400 or 500 amps, you'll sit there and you can watch that braid with a thermal camera, and you'll see where the braid bends. It gets hot. It's an amperage restriction. Even though the case is doing most of the work in this application, and the heatsink's actually doing even a majority more of the work. Okay, as far as carrying the ground. So we replaced that with a solid copper piece of bus, and then I went and did this amazing thing. I got out a lock nut, or a lock washer, and I put a lock washer on the backside, and then I held this with a closed end wrench, and then I sat there with a ratchet and made this tight so it won't spin anymore. It's amazing. Behind this, by the way, I cleaned up the aluminum, so it's got a good pressure mechanical connection for ground. Oh, and we replaced the on-off switch. It's now brand new. The other one had an erectile dysfunction disorder here. I mean, like, seriously. There's not enough blue pills in the universe to make that sucker stand up straight again. So this was down, that would be off, that would be on. Went from less than woo to almost a little bit of woo. So now we've got a brand new on-off switch. Cleaned all the burn out of it, cleaned up all the solder flux, like I said, checked every cap. So now what we're going to do is we're going to play with the output tune and the input tune. Remember, we had about a watt worth of reflect with just 20 watts going in. So if we times that by, let's say, 200 watts, we now have 10 watts coming back. So let me do that magic. But as far as this internally mechanically is, made you look, is okay. It's good to go. So on that note, let's go play with the tune. Okay, so now, as you can obviously see, I changed the output tuning network quite a bit. I added a doorknob. My main fear was that this capacitance tube, because it only had a single wrap of Teflon on it, its kVA rating would be inadequate. So when they really went to go step on this box, it would end up arcing through the output tuning tube. For a daily cruiser, probably would have lasted forever. As far as like a shootout box, like you're going to stand on it, not my thing. The only other thing I wish I could have done to both boxes, but neither one of the guys said anything about it, and I didn't think anything about it, but is that we would have added a secondary switch, a relay lockout switch, so it just locks the relay on. As soon as you turn the box on, it locks the relay down. So it'd totally eliminate the auto key circuit over here in the corner. But what I did is I got rid of this, which is how the input network was held up. And instead of having all this squished together, I spaced it out and made it all the turns even. Then I built a little stand for it to stand on, so this is now fixed. And then I moved the output tuning tube over here to the input, so it'd be more within its kVA range, and then used this capacitance tube here on the output side. So, still in a bench power supply. Show you drive, 1000 watt slug and peak again. Same 20 watts worth of input. Now what we're looking for is just a little bit more power. If I remember correctly, this thing was doing about 550 and some change, right? So we picked up about 75, 80 watts. But where most of that comes from is this. See how that needle's falling back? Instead of going forward up to 1.5 watts or a watt or whatever it was, now it's dropping. Some more drive we put in it, the more resonant it's going to get. Okay, now it's time to grab the Bench 2 pill, put this thing on the 1000 amp supply, and let's see how far we can take it. One more little small detail here. It's a very specific file. This isn't your mom or your wife or your sister's you know, fingernail file. This is a very specific. It's specifically designed for cleaning contacts, relay contacts, and points in vehicles. It's got diamond embedded little chisel sticks in it, little pixie pube hairs off of little angels in it and stuff that make it the right texture. Okay, now I know that guy's gonna be able to hear through it, talk through it, and it runs. Let's go max it out. All right. So I'll put this in 1x. Still 1000 watt in peak, 1000 average, 5 watt slug in reverse. So our voltmeter hooked up to our 1000 amp power supply, variable voltage supply. And we've got our 2-pill, which we are going to run full out at about 400 watts worth of drive into this thing, which is going to hit it pretty hard. So let's look at our voltage. So we're falling to 14.3. Land it in a corner, obviously. Let's go ahead and go up to 2x. So now full deflection is 2000 watts. 1900 and some change. Now we're seeing almost 800 bird out of it. And that's on 13 volts. Pardon me, 14.3. So, let's go down here. Let's bump it up a little bit. Oh, we'll do 15.5. That looks good enough for me. And now we'll go to the corner. Hello. 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 2000 watts, give or take. Hello. On 15 volts. So basically what you're going to get out of it on automotive use. It's dead on the money. So here's the other thing I wanted to point out. Is this little Anderson clip that's on here really is not right. Let me show you why. That's a 150 amp surge Anderson clip. Let's hook up our ground probe, or our amp ring on the ground side. Easily over 100 amps. You're going to see why that's going to become a vulnerability here in a minute. Now we all know fully chooched out, snotched out, this thing is going to pull close to 200 amps. So there's a 50 amp window that clip can't carry. So let's keep on going up. Stop just right below 17 volts because I don't feel like buying nobody no pills. If this blows up, I don't want it to be at my hands. Okay. 17 volts. Dropping to 16.5. Of course, we're burying that now in the corner. So we're going to take this up to a 5 times multiplier. Reading that middle scale, adding a couple zeros, right? 1,000, 2,000, 3,000, 4,000, 5,000. Okay. 2,500 watts peak. And 1,000 bird. Amp draw. 130 amps. Now here's the scary thing. Is if we were going to probe the voltage on the inside of this, you'll see it's falling down to around 15. Hence the reason for all the different wires and why you got to have a good connection, is you lose so much from your feed point to the inside of the amplifier. Now, I dare not do the next step of this little battle. That'd be hooking up the derail radio for max bird numbers underneath this kind of volts without having a fan on here to move some air. So let's do the last little bit of this process. Let's put the lid on it and check the fans. Looks pretty, don't it? A lot of people are going to see the inside of this, I have a feeling. I just have a feeling. Alright, we had to spend a little bit of time tinkering around trying to get the fans to run. The resistors that are coupled to the ground for the fans had slipped over and weren't making any good contact. So we moved those over so they're underneath these two screws, and the fans took off. Okay, so changed a couple things on the workbench. Still 1,000 watt slug in 5X, so that's 5,000 watts. Here's our 5,000 watt slug in average, and our 5 watt slug in reverse. Now we're on the D-rail radio, and I squeaked the power supply up to 17.2, which it won't hold that. And we got our little battery clip here. So let's look and see what we're doing for absolute peak power. About 2,500, 2,400. But look at our average numbers. 20 or 1,700, 1,800 watts, somewhere in there. Our voltage is dropping to 16 and a half, and our amp draw is 180-ish amps. Now the fans are falling down because the amount of voltage drop that's going in inside the cabinet. Mr. W, I'm here to tell you, you're going to want to go to the welding connectors like what Mr. R has got on his box. And you'll see even more power output here and bigger numbers here. But this is the end as far as I can test this little guy. Now I went ahead and I put all the screws in the cabinet because most of the structural strength of the cabinet comes from them screw joints. If you just put a couple screws in it, you end up having a problem. It gets just a slight little bang and chipping, and you end up banging and bend the cabinet all up. So I went ahead and I used the extra screws to give it a little bit more rigidity. It's very well earned. Well, gentlemen, I'm on a huge hurry with this one. I've got to disconnect it. I literally got to run in the house. Gots to get a shipping quote on both of these things. I got to get paid and get them out of here today because they're on a tight timeline. So, on that note, I'm going to say, gentlemen, thank you for tuning in and checking it out. I'm sorry I wasn't cracking funny jokes, but I was really concentrating, just trying to get this sucker done. Get it out of here, get it down the road, make it go kick rocks some other place. This thing is rocking, and it's rolling, and it's doing its thing. If you guys like what you've seen, take a second, click subscribe. Do me a favor. It makes both of us feel better. To watch the little subscriber number go up, make sure to hit the notification button. That way you can follow along with the rest of us. Seriously, give me a thumbs up if you like what you've seen. Quick little retune. Went through and polished these puppies up. Now they're ready to go. Mr. R and Mr. W. Gentlemen, and all of you guys, I thank you very much for all these projects that you're sending up here and you're entrusting me to work on every single time. Now I've only got about 680 more to go. It's currently in-house. Guys, I gotta get. I appreciate you all. I'll see ya. Bump, bump, bump from the biggest dock in Idaho.